Have you ever pondered the invisible forces that guide our universe? Today, we're diving into the world of vectors, the mathematical entities that have both magnitude and direction. These handy tools are fundamental to understanding physics and engineering, but they also pop up in computer graphics, machine learning, and even biology. Our first stop on this journey is the unit vector. This vector, as the name suggests, has a magnitude of 1, and its primary role is to denote direction. It's like a compass pointing the way but not concerning itself with distance. Next, we have the negative of a vector. This vector shares the same magnitude as a given vector but in the opposite direction. It's like walking the same distance but heading the other way. Equal vectors, on the other hand, share both magnitude and direction. Think of them as twins, identical in every way. Collinear vectors are a bit more complex. These vectors act along the same straight lines or along parallel straight lines, either in the same direction or the opposite. They're like trains on parallel tracks, heading the same way or opposite ways, but always along the same path. Coplanar vectors are vectors that lie in the same plane. These vectors are like dancers on a stage, moving in different directions but always staying on the same level. Lastly, we have the zero vector. This vector has zero magnitude and no specific direction. It's the quiet observer in the world of vectors, not participating but always present. Now that we have our cast of vectors, let's talk about how they interact. Vector addition follows the law of the triangle. Imagine you have a triangle and two sides are represented by two continuous vectors, vector A and vector B. The third side of the triangle in the opposite direction represents the resultant of the two vectors, vector C. But what's really interesting is that vector addition is both commutative and associative. That means that A plus B equals B plus A, and A plus B plus C equals A plus B plus C. It's a friendly operation, allowing for flexibility in how you add your vectors. And for those times when you have more than two vectors to add, that's when the Polygon method comes into play. This method is an extension of the triangular law of vector addition. If a number of vectors can be represented in magnitude and direction by the sides of a polygon taken in the same order, then their resultant is represented in magnitude and direction by the closing side of the polygon taken in the opposite order. To summarize, vectors are mathematical entities with both magnitude and direction. They come in various types, including unit vectors, negatives, equal vectors, collinear vectors, coplanar vectors, and zero vectors. Vector addition follows the law of the triangle, is commutative and associative, and can be calculated using the Polygon method for more than two vectors. Understanding these concepts is crucial to many fields, from physics to computer graphics to biology. The world of vectors is vast and fascinating, and we've only just skimmed the surface.